Did you know there's something called the leaf theorem? This was a particular paper that I saw on Viaxra by Marciano Lagarde, and it actually just talks about finding the area between two curves that sort of create that leaf shape, and it looks like it has a lot of significance. So in the document, you have the square root of x, and then you have this function that's modeled by x to the power of n. And if I increase the values of n, you're going to see that this leaf shape sort of just gets a little dissolved, and it's going to continue stretching on this way. But what we're trying to do, or what it's claiming, is that this area, as n approaches infinity, in other words, if the function continues to sort of spread out this way, perhaps touching here at 1, then the area is going to be 2/3. And now check out this other leaf. Here we have the function x to the power of n, and here we have the function x to the power of 1 over n. So it can be the square root of x, the cubic root of x, the fourth root of x, and so on. And as we continue to increase the value of n, then what's going to happen is this area will slowly approach 1. And it sort of makes sense because this is going to go ahead and just spread out here to these edges, 1 and 1. So here's the first proof. We're trying to find the area between these two curves, and now we're trying to make n approach infinity. So we're trying to make n get as big as possible. You can easily do the math here, and we end up having 2/3 for the first integral, and this one we end up with a fraction of 1 over n plus 1, where the limit as n approaches infinity is 0, so we have 2/3. And the next one is just as easy. If we have the integral from 0 to 1 of x to the 1 over n minus x to the n as n approaches infinity, we can very easily do the math, and we arrive at these fractions here at the end where n approaches infinity. But of course, the first one is going to approach 1 and the second one approaches 0, giving us an area of 1. Well, I think that's pretty fascinating, but why is it so important? Well, according to the author, we can use these for areas like analysis, probability distributions, and numerical methods. But regardless, I think it's pretty cool for people to continue writing these types of math concepts and putting them out in for the world for us to enjoy.